Hello student, in this video I am going to discuss about two-dimensional viewing. This is a new topic. So, few basic terms about viewing pipeline. What is viewing pipeline? To go for that, first I would like to mention about what is window. Window is a wall coordinate area selected for display. It means it defines the term window is what is to be viewed through your eyes, maybe through your camera, maybe that is what is to be viewed, that might be the window. And what is viewport? An area on a display device to which a window is mapped. Means that window, what is to be observed, what is to be viewed, is mapped to another window, or you can say another display device. It might be your monitor, it might be your mobile phone screen display, it might be another device which displaying your window that here we are mentioning. The window is that window which is defined as what is to be viewed. So viewport is that area on a display device to which a window is mapped. It's mapped, it's connected. So it might be a portion of your display, it might be a whole display. So that is the viewport, which defines basically the where it is to be displayed, Next, what is viewing transformation? The mapping of a part of a wall coordinates into device coordinate, that is viewing transformation. Means we are mapping the part of a wall coordinate or wall coordinate scenario, or you can say a hilly area or a natural scenery. Suppose we want to take a part of it from the window. What is to be viewed, what has been viewed is mapped to your viewport. That is the transformation of viewing. Okay, so a window could be rectangle. So a window can be any size, but it can be rectangle, but it can have also many orientation. But for our understanding in this course, we'll consider about only rectangle window. Here you can see this is the wall coordinate. So the reference coordinate you can see here. There is x max, y max, and also xw mean. This is wall view, or we can say wall view or wall coordinate view from that window. For that window there is a maximum point, there is a minimum point. For both boundaries there is 4 boundary. To design that boundary, it has used xw mean, xw max, yw mean, yw max. So through that window, what is viewed, that the part of that hill has been viewed, and then a hill or mountain has been viewed. That part has been mapped to this device coordinate. That is also we can say xv mean, viewport mean, xv max, viewport max. So that viewport has also a defined boundary. So that window is mapped to this viewport. Okay, that is two-dimensional viewing. So you can see here what are the stages while we are transferring, or we are that viewing transformation occurs. First, the model coordinate is used to construct the wall coordinate. WC, MC means model coordinate is used to construct the wall coordinate. Then wall coordinate is converted to viewing coordinate. Then viewing coordinate is converted to normalized viewing coordinate, and then only normalized viewing coordinate is converted to device coordinate. That is the whole picture of transferring the wall scenery to your device through a window and mapping with the device viewport. Here you can see it can be rotated, that viewport or the window of viewing is rotated, but here in the normalized device coordinate, that is stabilized, that is maintained. Okay, but the world reference coordinate is like this way, but the viewing coordinates is tilted, and that is why the window is tilted. And but this part is mapped to this point, and this is normalized by 0 to 1, and 0 to 1, that is the maximum. Okay, so using viewing effects we can apply zooming in or zoom out. We can pan effects, PanFX means moving fixed size windows across the various objects in a scene, successively mapping different size windows on a fixed size viewport. So here you can see that viewport size is fixed, but our viewport position is fixed, but the world view can be changed. It can be zoomed out, it can be zoomed in using only that viewing transformation pipeline, following that mapping technology or mapping concept. And also, and that we don't think about the viewport device, actually that is why device independent. So only depends upon that how we transform how that viewing into viewport, and don't think about the device and all, because it follows through a pipeline and it follows through a normalized coordinates. Here you can see this is one world view, and this is a tilted view coordinate. So view coordinate can be different and world coordinate can be different. Okay. Here you can see, suppose this is the world coordinate point xw, yw, and you need to map it in the viewport xv, yv, then it will follow a certain procedure. The ratio between this from this point to this x boundary xw mean should be the ratio between this distance and the distance between this boundary should be equal to this distance, the between the ratio of this distance to this distance should be equal to the ratio of this distance to this distance, means x direction distance. In the same way, the ratio of y direction and the y direction boundaries, and again the ratio of this direction and this direction boundary should be equal, because in that case only we can map the thing, and in that way we can display the point in this viewport in your monitor. This point might be in the window port, but your viewport should display by maintaining the same ratios, so that it maintains what is need to be maintained and what has been seen through the window and where to be displayed in the viewport. So that the same thing I have said, the ratio between the viewport to the xv minimum and viewport boundary xv max, xv minimum, same way yv minus yv minimum, yv max, yv minimum, you can see in the previous year also, xv minus xv minimum divided by xv max minus xv minimum, or yv minus yv minimum or yv max minus yv minimum should be equal to the world coordinates, same way. So using this equation 2, you can reduce it to this equation, xb can be equal to this equation where sx is this much. So if you follow the reduction procedure as per the book, you can reduce it to that, so that xb and yb can be calculated by having these values of the boundaries of viewport, values of the boundaries of window, and the values of the window coordinate. And again we can transform a simple viewport, one viewport, or you can say world viewing coordinate window. This is viewing coordinate window can be transferred, or it can be divided in different monitors, or you can say different viewport. This is one Windows screen 1, this is Windows screen 2, and this is Windows WS1 window for this part with WS2 viewport. So it has been separated. This viewport has been separated into different monitor. So in that way, we can suppose we need to do some calculation or computation in these pictures, so we can separate it out in different monitors so that the workload can be distributed. So in that way, that is why that workstation info transformation is a very good application in this kind of concept of viewing in case of graphics. So to view, or what has been viewed and where to be viewed, in that part one major operation is there, that is clipping. Means identify those portions of a pictures that are either inside or outside of a specified region of space. So we need to identify those portions of a picture that are either inside or outside of a specified region of space. That is clipping. And what is clip window? Clip window is the region against which an object is to be clipped. Actually, the clip window is nothing, basically almost similar to the window or the viewport, but it is the main port, or it is the window which is used to select those region that is need to be displayed in the monitor. Okay, so the shape of the clip window might be different, but we'll try to understand through only rectangle or square shaped window. There are lots of other operations of applications of clipping. Basically, viewport clipping is main part. It can reduce calculation by allowing concatenation of viewing and geometric transformation matrices. So by applying directly on the window clipping, on the window or world coordinate clipping, it will reduce the calculation by allowing concatenation of viewing and geometric transformation matrices. So in that way, after clipping the main what is to be viewed directly on the window, then we can directly add the transformation pipeline to display it on the viewport. So that way we can reduce the calculation. But if we do the clipping on other side, it might increase the calculation. There are different types of clippings are there: point clipping, line clipping, area clipping, curve clipping, text clipping. But for our course, we'll try to go for point, line and area, basically more focused on line and area. There are lots of algorithms are there, in case of line clipping, there are Cohen-Sutherland line clipping algorithm, Lian-Bursky line clipping algorithm, there is Nicolli line clipping algorithm. Also in case of area clipping, there is Sutter-Hodgman polygon clipping algorithm. There is Sutherland-Hodgman Euler-Atherton polygon clipping algorithm. There might be other algorithm also in the book. Also, we'll try to go through each one of them for understanding. So that is the part we need to discuss in this topic. It is a big topic, and try to go through it. And also, please try to be focused on this topic. This is very important, because it is very much mathematical also. And also here you can see in case of line clipping, actually here this is the before clipping scenario. This is the we can say world coordinate or world viewing, and this is the window, and we can clip in the viewport to reduce the operation or reduce the calculation. So in the viewport we are clipping the lines, so that those lines will be clipped. So our main motive is to find which line will be outside, which line will be inside, or which points or which fraction of the lines will be outside or inside. That so the way we will try to find out, we'll try to apply different algorithms regarding line clipping. We'll try to go through it in next videos. Please try to go through the content related with this clipping, so that if you can find it easy to understand. So if you have any problem, if you have any doubt regarding this also, please let me know. We'll try to resolve it over Google Meet. Thank you.